Hello everyone. Today we are going to be going over the parts of a microscope. This is very much a mechanical method. We're going to go through the parts, show the labeling, their use and function. I will probably have another video where we look at some cool stuff, probably yeast, because yeast is easy and looks nice under a microscope in a wet mount, but maybe some other things as well. If you would like, under the eukaryotes, there is a bunch of videos, mostly algae, but also some yeasts, to take a look and see what it looks like under the microscope itself. So let's start off with our microscope here. This is an example microscope. This is one of the teaching scopes we have here in the lab. Let me pull off the dust cover. This is a Leica DM 75 microscope. And as you can see, we are going to be going through this entire thing. For those of you with motion sickness, I will try as best as I can to limit the movement of the webcam, but there will be movement on this webcam. I will try to give everyone a heads up when that's coming, and hopefully it's not too much of a problem going through. So with that in mind, let's start off with our first bit of movement, and we're going to start at the top of the scope. These are our eyepieces. These are also known as the optical objectives. They are a 10 times power. And what we're going to do is we're going to look at the very base of, base is down here, the top part of this. You have your objectives. I'm going to show you how you look through. You look through just like this. For objectives with two eyes, like these have here, you typically will have in one of them, in this one here on the right side, a needle, and this is a pointer, and on this one on the side here is going to have your micrometer. The micrometer is used for measuring whatever is on the stage, which is down here, and the needle is just to make sure that you're set up properly. Now I'm going to move the webcam again. This time I'm removing it from our mount so that we can take a look. Right like this. Here's what your microscope is going to look like. Again, your two optical objectives. This here is a measurement tool that measures the distance between your eyes. This is, once you know these numbers, you can set. As you can see, that's what mine's set as. It's hard to see with this webcam, kind of blurry. But for me, it's set up at, on the left is 70, and on the right is 65. That's just my distance between my eyes. And as we go down, we're going to take a first look here at our camera. This is a Leica ICC50 camera, and notice its location. The location of the camera is above the nose piece. So if we chart where light's going, light starts down here on the base, comes up through the diaphragm, up through our condenser, onto our stage with our whatever we're measuring on the stage itself, through our objective lenses, into the nose piece, into the camera, and then we see through the ocular objectives. Now, as we look down here, we do have separate, different ocular objectives. This is a 10 times objective. This is the 10 times. This is the 10 times objective. This is a 4 times objective. This here, this blue one, that is our 40 times objective. And then we end with our oil immersion lens right down here. Now I'm going to pull out a different objective, and we're going to go up and look down again. So this might be a bit of a shaking movement. So if you have motion sickness, I do apologize. Now, this here, it's hard to see a little bit, but that's because of the webcam itself. If we take a look, we have writing here on one of these objectives. This is a normal bright field objective. It's plan N, that's the type of objective it is. In this case, this is from our Olympus microscopes. We also have our 40 times, and then we have this number here, which is 0.065. That is the numerical aperture on an objective lens. So for our 40 times objective, in this case it's 0.065. For our 10 times objective, it's 0.1. For our for our 4 times, it's 10. For our 10 times, it's 0.25. And for our oil immersion lens, you're looking at 1.25. You will need to know those, and you find them here on the objectives. Now I'm going to pull in another objective just so we can take a look at it. Notice how this one has green writing. Now there is a difference between these two objective lenses, and it's not the magnification. The magnification is the same on both of these. It's both 40 times. The difference is that this one, the green one, is a phase contrast objective. And phase contrast objectives should only be used with phase contrast microscopy. Now, phase contrast microscopy is, instead of using a light field, you use a dark field. It's also known as dark field microscopy. We will not be doing any phase contrast microscopy this semester. However, I feel it's necessary, and really you should know the difference between these two. So we're going to put this off to the side here. Now, we are going to swing back to the microscope. This will be another time of possible movement for you. And this time we're going to keep it mounted so that we can take a look at our nose piece. Now, when we take a look at our nose piece, let me pull out some slides here. Now, I just placed on the stage itself, which is this part here, a slide. It is a prepared slide of Enterobacter aerogenes. And I'd like you to take a look at, once again, our microscope here. We have our base, we have our diaphragm, we have our condenser, which right in there. You have these here. This lower one moves in the X plane. This one moves in the Z plane. If we take a look at a Cartesian plane, X, Y, excuse me. Yeah, for you guys, this is X. Okay? Y, and then Z is up and down. So when we take a look here, this moves in the X. This moves in the Z, forward and back. Up and down is Y. And that is actually our course adjustment knob. So we have course adjustment knob, which moves in the Z plane. Excuse me, the Y plane. You have the fine adjustment knob, which is to help find exactly how what one of these would look like on here. And you have the upper knob here, which is the forward and back, or Z plane. Now, as we look through here, on our stage, we have the stage, which is this area right here. Stage clip, which is right here. Notice where our light's going. And it's important because we have to do a bit of calculations here. Right now, we're on the 4 times objective. Does that mean that the Enterobacter aerogenes that's on this is only magnified 4 times? And the answer is no. Because look at where we're going to be observing. If we're observing through here, we're also getting the 10 times magnification from our eyepiece. So that means that when we want to find the total magnification, it's the 4 times with the 10 times magnification. So our total is 40 times. But that is not what the camera sees. The camera does not get this. The camera just gets the objective itself. So what that means is when we're taking pictures, the pictures are going to be slightly smaller than what they would be if you were looking through. If you have a micrometer that is on one of the pictures that I give you, that will be through an objective. It will be a micrograph, which is us taking a picture through the objective lens, through here, with either this webcam or some other camera, and that will have a total magnification on it. What it won't have is if we come through here and we take pictures through the scope, or, and here's the big thing, if you're having results that are in the form of videos. A lot of the videos that you're going to see from us, all of the videos actually, are only going to be the nose piece magnifications. And that's because we are not observing through these, we're observing through this. And this does not get the 10 times magnification. So let's take a look at what else we have here. We have the arm. The arm is the part of the microscope that it attaches the base to the nose piece, and it supports the entire base. It's also back here where our handle is. Now, I'll remove this. How do we do basic microscopy? You should always start off by having your 4x objective locked in. Whenever you rotate your objectives, you do not touch the ocular objectives themselves, but you always use this textured black strip. What can happen is if you were to turn using your objective, that can loosen the objective inside the nose piece, which makes the microscopy much more difficult. These should always be finger tight. They should not be over tightened and turned so far in that you can't get them out, but at the same time, you don't want them to be loose. So when we rotate in increase. This is known as our oil immersion lens, and you always want to use oil with your oil immersion lens. Now, how do we do basic microscopy? Well, let's start off with our Enterobacter aerogenes prepared slide. We are going to put that here. First thing we do, turn on the light. Here's your light switch. Light comes on. I'm going to move the camera again. Now I'd like to take a look at the other side, right over here. As you can see on this side, there is another coarse adjustment knob, another fine adjustment knob, but there's also this here. This changes the intensity of the light, the LED light that is coming out of here. Down here, it's kind of hard for you to see, this adjusts our diaphragm and our condensing unit to whatever, really ideally, it gives you the best amount of light for the specific type of magnification that we're on. So this would be 40 times, this is meant for 100 times, and the like. Now, I'm going to raise the stage slowly using the coarse adjustment knob. Once again, the coarse adjustment knob moves the stage up and down in the Y plane. And as you can see, the condensing unit is rising. And I want to get right in there. This here is either a light bulb or an LED. This microscope uses an LED, but your older microscopes are going to be using light bulbs. This, as you can see, it changes. I'll look right in through there. This changes the amount of light that goes into the condensing unit. And we're just going to bring you back around. Now, basic microscopy. You want to look through both eyepieces, like so, if you can. What do I mean by if you can? There are some microscopes, typically they're older microscopes, that only have one eyepiece. In that case, you want to use only one eye, but have one eye on a black surface. That way you're not squinting. Squinting, it changes how light enters your eye. That can cause headaches, migraines, nausea. It's really nasty if you don't properly use microscopy. If you have glasses, you can look through your glasses, just like I have glasses and I'm looking through. We're going to take a look down here. And using the coarse adjustment knob, bring up your specimen into view, starting with the 40 times objective. Now, for some things, like our Enterobacter here, it's not stained, which means that it might take us a bit to find an actual good location. As I readjust this, and it might take us some time to find our specimen. Now, once you've found your specimen, the next thing you're going to do is swing to the next power. Notice how I am not touching the coarse adjustment knob. The reason I'm not touching the coarse adjustment knob when I increase power is that all of our microscopes here in the lab are what's known as parfocal. Unlike bifocal, which is two lenses, parfocal means that as we increase power, we don't have to adjust the coarse adjustment knob. We simply need to look through and adjust using the fine adjustment knob. Next thing we're going to do, increase our power again. And with this one, we have to readjust our stage, which I will do on a different time, because as you saw, the objective hit our prepared slide. That should not happen if your stage is properly calibrated. This is not properly calibrated. I will have to go through and check that. But we can still do the demo. Next thing we're going to do, we're going to increase power to our oil immersion lens. In order to do that, we need this right here. This is immersion oil. And this is called oil immersion microscopy. Take a look in your book. Both the majors and the nursing books have very nice drawings on exactly what oil immersion microscopy is and why it works. In short, when we're set up like this, there's an amount of light that's coming up through here, through our specimen, and then is going off the edges. This light is light that's lost that could be used to help us more easily see our organism. What oil immersion does is that takes that light and refracts it more towards our oil immersion lens. So let's take a look here. Turn it halfway. We're then going to take our oil immersion, our immersion oil I should say, a single drop on our specimen, and swing it in. And right like that. Now, I'd like you to take a look at how this is done and what it looks like closer. It's going to be very difficult to see, but you can see that there's a small bubble of oil that's just touching the base of the objective, and that's really what we're looking for oil immersion. There will be another video where I go through this process with the camera up here, And we'll take a look at something cool, probably a bacteria that I'll simple stain. And we're just going to take a look and see what we get. But that's the basis of oil immersion microscopy. Typically at this point, you would use a calibration factor to determine how big your sample is, make your observations, and draw it out. So how do we tear down this? Well, the first thing we do, we swing out past oil immersion and remove our sample. Next thing we do, lower our stage. We take lens paper. Lens paper is thin paper that is designed specifically to be used with lenses. Our ocular objectives here are very expensive. The last quote I had for one of these oil immersion lenses that we're going to be cleaning was around $1,500. So what you need, our lens cleaner. Our lens cleaner, we get it from VWR, but we have bottles from Fisher. And we're going to start by tapping. We do not scrub. Scrubbing does not work. It scratches the lenses. Put a little bit of the lens cleaner and then dab it like such. Again, not scrubbing. Swing it back. Turn off the light. Lower our stage all the way down. Then we're going to take our dust cover and put it over the top. Before I close out mine, I do want to show you how to carry one of these. You always want to support with the base. Start with your dominant hand. I'm right hand dominant. So when I carry these, I support the base with my right hand, and on the left, I'm going to shift you over again, is the handle. You support the neck with your non-dominant hand. Always use two hands when carrying a microscope. You don't want to swing it around and smash it into other people, places, things, damage the lenses, the oculars, or the like. Next thing I'd like to show, oddly enough, is cleaning specific objectives. And for that, we need to shift our camera. This should be the last time we have a camera shift in this video. Put you down. For this, we're going to need our demo objective. We're also going to need a sterile tipped applicator and more of our lens cleaner. We're going to start by opening up our tipped applicators and holding it in our dominant hand. Again, I'm right hand dominant, so I'm doing this with my right hand first. And we're then going to wet the applicator with our lens cleaner. To clean, we're going to take our tipped applicator and gently clean inside and the outside to remove any dust or grime that is inside of here. We can also, same thing, very gently dab down here and around the edges to cut any type of oil. Then we're going to take our lens paper. I have some more off to the side here. I just need to tear off another bit. And dab dry. Like so. Typically, we would do this only with we would do this typically anytime we need to clean the microscope. Typically, that's done about once a week here in the lab. But a full deep clean of all microscopes are done at the beginning and the end of each semester. Sometimes we need to clean them as needed. That happens. When that does, your TA, as well as myself, are trained in how to clean these. You, as the student, are not required to disassemble our microscopes. and clean them and clean the objectives like I just did. That is something for the TAs and myself. Typically in a lab period, we would come through, we'd see, yep, it needs to be cleaned, put it off to the side, bring you another microscope. And that is our base microscopy video. There will be another video of me looking through the microscope and you seeing exactly what is here once I do a bit of staining. We'll see what fun stuff I can come up with.